Welcome back to Engineering Open House Day Live, to this live-a-thon. I'm Mark Reynard, your host for today, where we are giving you an exclusive insight into what it's like to work within science, technology, engineering and maths. And can I say, what a day we've had so far, haven't we, Guy? What a day it's been. Oh, brilliant. Oh, we launched the show this morning with an amazing first episode that took us to outer space, and we met epic engineers, including Sophie Harker, Jack Hesselwood, Mr. World. We delved into the world of electricity with Danielle George and Shrouk El Attar, and then we zoomed around learning all about transport engineering with Ella Podmore. All the while, we've learned how to make pizza box solar-powered s'mores. We've seen how balloons can defy gravity. Sounds epic, doesn't it? And don't worry if you've just tuned in, as all the episodes will be available on demand throughout the 6-week school summer holidays, which is going to be brilliant too. So now we are powering our brains in this next episode with our focus on energy and sustainability. And there are still more cool engineers coming into the studio live who are going to give us an insight into what they do. Plus, they'll be taking part in the best bit, the Engineering Open House Day Challenge. But that isn't all. Oh no, we have had so many virtual events going on in today all around the country that our media hub has loads of stuff available for you with Transport for London, Apple, rocket makers, plus so many more. So bet you never knew that engineering was quite so varied. But before all of that, I want to hear what some of you at home who are using our hashtag IET Open House on social media have to say. So let's have a quick look. Well, there we go. Look, there's a fantastic range of activities on offer today and beyond through IET Open House Day. Thanks for that one. This one's from Peterborough STEM First. Jack Hesselwood at the IET. That's an impressive paper aeroplane effort. Hashtag the IET Open House. It was brilliant though, absolutely. Any more up there? No, I think we got some more coming. Oh, there's one more coming in there. We sat watching IET Open House this morning and now looking forward to the solar-powered s'mores. Please don't make us choose between Team Greg or Team Maddie. No, I had some s'mores and they were lush. So it's great seeing that some of you are making those at home as well. And I think we've all earned a treat, that's for sure. And it's even more amazing to see that there are plenty of people being inspired into STEM. So who's ready for more? I sure am, especially now I've had some energy put into me. Well, energy can be found in many different forms. That's right. It can be heat, light, motion, electrical, chemical, nuclear, and gravity, which we heard about from Dan earlier. But all these forms of energy can change something that it touches. And like we saw earlier with Maddie and Greg, they use solar energy to melt the marshmallows and chocolate to make the s'mores. Everything on Earth contains energy in the molecules that it's made up of. You, me, your dog, your desk, your bike, trees, everything. There is a continual transfer of energy between everything in our universe. Now, we even produce energy when we eat. This energy makes us feel like more awake. It allows us to keep warm. We use our brains, keeps our heart beating, breathe, move, do all the running aroundy things that we want our bodies to do. This is called metabolic energy, which is why your mum and dad and my mum and dad still always say, make sure you eat breakfast before school. Otherwise, you won't be able to use the energy from breakfast to learn about all the lovely world of STEM. It doesn't just come from the food, though. It can come from all sorts of sources, including steam, light, water, wind. So let's go back to see Maddie and Greg, where they're going to show us how we can harness hydropower using a water bottle, a watering can, and a paddling pool. How's it going, Greg and Maddie? I can't wait to see your next experiment.
Okay, Mark, I hope you're ready for this one because this could get a little bit wet.
Did you know that you can generate energy from moving water? Because that's what this next activity is all about. We're going to be harnessing hydropower.
Hydropower. Hydro comes from the Greek for water.
Yeah.
And we love hydropower because it's a renewable energy, just like solar power, because water and sunlight, they don't run out.
Yeah, we can use hydropower to generate energy from any moving water. That could be a river flowing down a hill, or the tide that's moving in and out, or even a waterfall. All of these things generate a lot of energy that we can turn into electrical energy.
We have been harnessing hydropower for years.
Yeah, over 2,000 years ago, people were using moving water to turn a water wheel on a mill that would grind wheat into flour.
Nowadays, though, we tend to use flowing water to to move over a turbine
Yeah.
to generate electricity. A little bit like wind blowing over a wind turbine.
Yeah, in fact, a tidal energy plant, this is where we're using the tide, the moving water, to generate energy. They're using underwater turbines, and really it looks a little bit like a wind turbine farm, but just an upside down.
Upside down.
Yeah.
So today we're going to show you a really simple little make to make your own water wheel, and this is what you could use to do it.
We have a plastic bottle. You can get any plastic bottle from the recycling. Something that used to have fizzy drink in it, be quite useful. A stick. We've got a piece of bamboo cane here. The important thing though is you just need the stick to be able to fit through the nozzle of the bottle. We've also got some index cards. You could use birthday cards. Thick card.
Any old card?
We've just stick some index cards together, so anything roughly that size.
Cardboard
some silver
box.
foil, yeah, which we're going to wrap up the cards with, and then some scissors, some sticky tape, some string, which we've actually stuck a bottle cap to the end to, which we'll explain in a bit. But then importantly...
Yes. This is the thing. This can get messy.
Yeah.
So maybe do this one outside, or if not, set up a waterproof area inside, hence our very small paddling pool.
This is our splash zone.
And you'll need some water.
Right. Okay, so first of all, you want to get your plastic bottle, and you might want to ask a grown-up to help you make a little hole in the bottom. The idea is that your stick, your cane, is going to go all the way through, the hole in the bottom, oh, other end. There we go, perfect. You're going to go all the way through the bottle like this, so that it will freely spin. But that's not all. This is going to be our water wheel, so we need to give it some paddles. Might be tricky for you to see, but I have already pre-cut 5 lines in the plastic bottle, and those lines are the same length as our index cards, just like this. So the idea is that you want your index cards, your pieces of card, to just be able to slot in to those slits that we've already pre-cut. Can be tricky, so again, might want to ask a grown-up to help you with that.
But we need to make these waterproof.
We do.
That is key.
Yeah, so the way we're going to do that is wrap them in some silver foil. You could waterproof them however you like. Maybe you could use some plastic, some different cling film, but you just want to make sure that your paddles are flat and smooth. I'm actually going to, are you wrapping yours up a bit like a present?
Yeah.
Yeah, me too, that's what I'm
Just
doing.
for fun. Okay, so... Okay, and a bit of tape.
Beautifully done. Yeah, if you keep it neat and tidy, it will make your water wheel
I tried to be prepared and have the
smoother.
tape stuck to the table. Oh, it's all right, I got it
Did
off.
that work all right?
Almost a disaster.
All right then.
Perfect.
So I'm just folding this
like
last little
that.
bit. Can I have another piece of tape?
Yeah, hang on.
The problem with sticky tape is that it's
Sticky.
see-through and clear.
Okay,
There you
ready.
go. That's it, neatly pipe that down. Nice. So we now have our 5 paddles, our little parcels. Something that might make it easier for you to create your 5 cuts is actually at the bottom of a lot of bottles. You sort of have these 5 little stands. So we've just lined them up with those.
Yeah,
Useful,
great,
useful
great.
for getting your positioning correct.
Okay, I'm going to start slotting them in.
Yep, so we've now got 1 paddle in each of the slots. We've sort of made our slots exactly the right size, so it should be quite a tight squeeze, but if you wanted to, you could always use a bit of extra sticky tape to just make sure they're nice and secure. But you want them to sort of be as far out as possible, so you've got as much surface area for water to land on. One more?
One more.
Well done!
Hey, almost looks like a water wheel.
That's amazing. So I'm just going to pull these out just so they're all roughly even the whole way round. How do you feel about that?
Lid, I think is next. That's not
so
too bad.
good.
Yeah, happy with that.
So you'll remember we told you that you might want a piece of string, and we're using a bottle cap. You could actually use the same cap from the recycle bottle. I've stuck the cap to a piece of string, just using some sticky tape. And now I'm going to tie the other end of the string to this end of the bottle, to the nozzle just here, which I'm just doing with a double knot because you want it to be tight and secure in place, like so.
Great.
So you want to make sure it's nice and tight because you don't really want that to spin around freely. Oh no, one of our paddles has escaped.
Don't panic, don't
You
panic.
can obviously take your time doing this and use as much sticky tape as you want to make sure everything's nice and secure. So you are now putting the stick back through the bottle. And this here is the water wheel. But to test it, to see if it works, we're going to need some water. So I'm actually going to spin this around, if that's okay, so we can use the other side.
This is where disaster could happen, but hopefully engineering will prevail. Right,
Before we
okay.
do this, before we get the water, let's tell you what we want to happen. So the idea is that we're going to pour water on our water wheel.
Yeah.
Hopefully the water will catch on the paddles and we'll find that it spins.
Yes.
As it does that, what we want is for the water wheel to lift the weight, which is our bottle cap on the end of the piece of string. So that's what we want to happen. 3, 2, 1, pour.
Come on.
Yes.
Yes. I'm missing the.
Oh, go on,
No,
go on,
come
go
on,
on, go
come
on,
on.
go on. Oh no, the paddles.
Okay.
It's going, it's moving.
Yeah, oh!
Yes, I'm going to move lower. There you go. I'm getting. Come
No,
on,
lift it
paddle.
higher, lift it higher, lift it higher. That's it, that's working. Yes, yes, yes. Come on, the weight's almost there. Come on, all the way. Come on, all the way. Sorry, I slipped.
There we go. I'm helping with the paddles.
Oh, a little bit more came out than I thought it did. I'm so sorry.
Wow. Okay. So I think that went really well.
Yeah, apart from that time I slipped.
What do you think happened?
I think it went well.
Okay, let's
Yeah.
explain what was going on there. So the moving water, honestly. Come on, tell us how it works.
Okay, so the moving water, the water was pulled down by gravity. The moving water pushed on the paddles, and that pulled the whole bottle round, and as it did so, that pulled the weight up. But, you know, we're looking at this, we're thinking, what could we do better next time? Because we're thinking like an engineer.
Yeah.
We're thinking, how can we tinker with this?
Yeah, we can definitely improve the design. So something that wasn't working for us was that our paddles weren't always in the right position. So I think if we taped them so that they were sort of like sticking up all the time, then we would know that the water would always land on the paddle that would help it move.
Yeah,
better.
perfect. We've had such a good day here at Engineering Open House Day. We've been super inspired by the scientists, the engineers, the innovations that we've seen. One of us got a little bit damp.
I think I'm going to go and dry off. But if you would like to see more STEM activities and experiments, then do head to the Engineer a Better World website.
Right. Oh, okay.
Can anyone help me pour this over his head?
Oh,
okay.
no.
Bye, my team.
Well, I'm glad I moved out of the splash zone. Oh, Maddie obviously didn't get the memo. I think she'll need a towel now. Whoa, isn't that cool how humans have been using hydropower for all of that time? And how you can actually try and make one of those at home with just a few things from around the house. So thanks, Maddie and Greg. It's been great to have you as part of the show, it really has. And to help us understand how organisations are thinking of ways to use more sustainable energy, we are also about to be joined by Amber O'Connor, who works at Siemens Energy. At the age of 26, Amber works as an equipment health monitoring and performance engineer and remote diagnostic service program manager. That's a great title, isn't it? I mean, if that's not an impressive enough job title, I don't think there is one. But she's also able to interpret a gas turbine's 3,500 data measurements per minute. She can interpret those, as well as leading a team to ensure they're running faultlessly in every region of the world. It sounds like some pretty impressive engineering work, if you ask me, and I'm excited to learn more about what she does. So let's welcome Amber O'Connor.
People being different is what makes this world so exciting and unique. I love being a nerd. I think it is great because it shows that I'm passionate, and for me it's engineering. I work within the aeroderivative gas turbines business of Siemens Energy. I am an engineering program manager for remote diagnostic services all around the world. I'm responsible for the end-to-end solutions, but I'm just a small piece of the puzzle, and it takes everyone to do their part to really make a difference. We develop products and services that really represent what our customers want, and that's what we do in Siemens Energy. Our world around us is fragile. Being a mom has definitely changed my approach to challenges just in general. My husband and my kids, they completely push me to be the best person that I can be. I love that I go to work and that I'm passionate about it. I miss my colleagues. We're in the situation that we are, and we have to adapt and overcome it. I am glad that we've had this opportunity to be able to try working remotely and create a new normal. In the current crisis that we're in, I provide remote monitoring solutions and actually taking care that their employees are safe, offer an essential service and keep the lights on, basically. As a working mum, I accept that there's certain things that I'm going to miss and sacrifice, but actually remote working has enabled me to have a lot more time with my kids, which is really cool. Engineering's definitely still got the stigma attached to it where it's a man's world. The best way to change is by educating, telling people what a STEM career really is, what does an engineer do, what do they look like. My daughter could grow up and she might want to be a mechanic, and that's fine. This world that we live in where anyone can be anything, we know it's not sustainable to keep burning fossil fuels. We need to protect the world for the future generations, because I look at my kids and I want to create a world that is safe for them, a world that's protected, somewhere I know that they're going to have their whole life ahead of them. In order to do that, it needs to start now.
Wow, we are here back in the studio and we've got Amber with us today. Let's hear it for Amber. Brilliant. Amber, you work for Siemens, don't you? Siemens Energy. Tell us exactly what you do there then.
So in Siemens Energy, I work in the aeroderivative gas turbine business, which sounds like a crazy title, but basically plain engines that we go and we put into a big metal box and we use it to, pump oil and gas or to produce power. And I remotely monitor those gas turbines.
Wow, so you remotely monitor, and they're placed all over the world doing their job,
Yeah.
that they're generating electricity or whatever, and you're sort of making sure they're still going.
Yeah, exactly. Making sure that, they're not breaking, helping customers resolve issues. Yeah, it's really exciting.
And just explain to us, what is a gas turbine and how does it work?
So I have like a really easy way of explaining how a gas turbine works, and it's with 4 words.
Right.
So it's suck, squeeze, bang, and blow. So I have a little model here.
Yep.
So the air comes in, so
Yep.
that's the suck, and then it is compressed through a series of blades, so that's
okay.
where it's squeezed.
Yep.
And then we inject some fuel in there, and then we ignite it. So that's the bang, and then it comes out the back, and it's that momentum energy that then drives blades round, and we churn that, that rotational energy, and then we convert it into electricity that we use day to day for
So
everything.
if it was a jet engine on a plane, a turbine, that would be pushing the air out behind, and then it gets faster, so more air comes in. But yours are in a box, and so they're generating power for something else.
Yeah.
So why do you need, a gas turbine generator you put them on oil platforms and all sorts of things
Yeah.
like that. What do you need them there for then?
So for our oil and gas, it's stored really, really deep down, like below the ocean. So we have to like pump it up. So we need a lot of energy, and then we also need to pump it from offshore to onshore. So you need a lot of energy, and gas turbines are really great at doing that.
And what else do they do? They're in the fields somewhere else and all over the place. What are they doing then?
So, for example, you've got like your paper mills, so producing your toilet paper. They need a lot of power to do that. So gas turbines can run those industrial purposes.
Really? So there's like units in the UK that are big factory and stuff that are run on gas turbines
Yeah.
and that we just don't know about as a sort of general public?
Yeah, exactly.
Wow. And how many are there of them sort of under your remote monitoring then? How many have you got?
So I have about 200 gas turbines all around the world that my team take care of.
Wow. And what do you think the future of the energy industry is then, looking forward?
I think the energy industry is going to change a lot. Obviously, we talk about going green, being carbon neutral, which is basically making sure that we're not damaging the environment. So as we move forward, we're looking at how do we put different fuels into our gas turbines so that they're not emitting horrible greenhouse gases. So stuff like hydrogen, or even just moving more towards renewables like wind and solar. I think they're going to become a lot more common, backed up by gas turbines, whereas currently gas turbines the majority of the energy.
So if you lost the sun, or if you, as in not lost the sun, but if the sun went behind in clouds and there was no wind, your gas turbine would kick in, give it a bit of time, but could be using hydrogen, which would then obviously, and then presumably you could use the wind turbines and the solar to help make your hydrogen that you used in the gas turbines in some way. So it would be kind of helpful.
Yeah, so we can extract hydrogen through electrolysis. So we're going to do an experiment later that shows you how you get hydrogen. But it's a really simple process. But obviously on large scale, it needs a lot of power. So that's where your wind turbines come in, solar. Yeah.
Brilliant. Because one of the big problems is obviously you need fuel in these turbines. And at the moment that would be gas or something else. And that gives off like, your greenhouse gases.
Yeah.
But with hydrogen, you don't get that, do you? If you burn the hydrogen, what's the sort of the gases that come out of that afterwards then?
So hydrogen doesn't release those harmful gases, so that's CO2, because we've broken that down. So, you get like water vapor and that's it. So you get that oxygen, and we're protecting the environment by moving to that. I mean, we've got a way to go because hydrogen's really hard to store, it's hard to move around, but we'll get there because we're engineers and it's what we do.
And you can make hydrogen from seawater, can't you?
Yeah, so water mixed with salt, which is the experiment we're going to do,
right.
You can get that hydrogen out of that H2O.
Wow. And have there been trials for hydrogen on these turbines yet?
Yeah, so we've actually been able to run our gas turbines on hydrogen for over 30 years.
Wow.
It's just that now we're trying to bring the content up, so we want to be able to run on 100%, whereas we've proven it with a blended fuel mix so far.
Brilliant. So it is coming. It's something that's going to be another way of creating energy without maybe having the sun and the wind, but still using a supply of something that's not going to affect the environment.
Yeah, exactly.
Wow, what a great job. Well, should we have a look at the experiment then?
Yeah,
Is that a good time, everybody? Should we go and have a look? That sounds fantastic. Let's have a look at how we make hydrogen from seawater. This is going to be epic. So there is a danger of explosion here, isn't there? No, there isn't really. I'm joking. It's okay. Right. So basically, I'm going to try and get around the side a little bit so we can get sort of a bit closer in. To explain me what we've got on here then, Amber.
Okay, so really simple. I have a beaker with water in, and then I've mixed salt into it, so it's salt water now. And then I have 2 test tubes with some graphite rods in. So they are my cathode and my anode.
Yes.
And then I have some wiring attached, and we're going to attach some batteries. And then basically what's going to happen is that we're going to put an electric current through this circuit, and in the one attached to my blue wire is where my oxygen is going to collect, and on my green wire is where my hydrogen is going to connect.
Wow. And what happens, I know this what happens to the water? Does it run out? I don't know how this can, does it run out of hydrogen?
I mean, so water is H2O, so obviously all of that water content has got hydrogen and oxygen mixed into it. So, this is a amount of water, but if you think of the amount of water and the sea span, like we can so easily extract hydrogen.
And so as you're making hydrogen and oxygen, is the water going down a little bit?
So, what you'll see is in the test tubes is water. As the hydrogen gas escapes, the water level in this test tube will go down.
Right, brilliant. Well, should we start? Are we all ready to have a look at this? We're going to actually make some hydrogen here in the studio. Right, Amber, take it away.
It might take a little bit of time to collect, so we can keep talking.
Oh, brilliant. So the batteries go on. They're
so
in,
the batteries
are they in
go
parallel?
on.
Oh, look at that.
And then you'll see that...
Whoa. So what are the bubbles coming off on that side there?
So the bubbles are hydrogen, and obviously I'm trying to collect
You're trying to collect some of them in there. I get you.
But what you'll see is the oxygen
there's
side,
little bubbles as well.
Little bubbles, whereas on the hydrogen side, it's a lot more.
And what are the little bubbles on that side? Oxygen.
So this is oxygen, and this is hydrogen.
So you're getting twice as much hydrogen as oxygen, because that's why it's H2O.
Yeah, exactly. So to speed up the process, I've actually attached 2 batteries to try and get some speed into there.
Yeah.
But you'll already notice
wow, look at it. It's properly filling up, isn't it?
So we started with the water about at the level of the cardboard.
Yeah,
so
and now we've doubled that up, haven't we?
Yeah, so if we let it go down a little bit, and then we'll
And then what are you going to do to prove it's hydrogen?
So if we're lucky, we might be able to use this and
that is a...
It's probably got the safety catch on.
Oh, it's got safety catch on.
Safety first.
Oh, yeah, it's just a lighter. I thought it was going to be something exciting.
But look, can you see how far down we are now?
Yeah, that's true. But if you're going to try this at home, which is quite complicated, which is why Amber's here doing it for us, obviously if you're doing this at home, make sure there's adults there. You know, please
Definitely.
don't get a load of batteries out and start sticking them in salt water. And if you're going to use anything with a lighter, absolutely make sure that there's an adult around. That's your warnings, okay? So don't be doing it unless there's a parent. Great. Amber, are we there yet, do you think? It's about three-quarters full, that
we're
tube
down
now.
here, so if we just give it maybe
We can give it a minute.
5 more
Now,
seconds.
the oxygen side, okay, if you took that out, is there a test we can do for oxygen?
So oxygen is not such a great energy source, so it's not going to have the same impact.
It won't do the things with the light, with the lights and all that. No. So it's the hydrogen we're after. The oxygen is a good byproduct, I suppose, isn't it?
Yeah.
We're nearly there. This is brilliant. And I know it sounds funny, but is the water changing colour?
So it might do a little bit, which is just the oxidisation sort of from
So it's the
wine.
chemicals and the oxidation of the cathode.
So if we stop this now,
Oh, this is it now. I hope you're in close here, guys.
what we'll try to do.
Okay, do I need to get this ready? Or are you going to do it?
You can do it.
No, I don't think so. I think you should do it.
We'll get rid of this one.
Yep.
So the oxygen's now just gone back
Yep.
into the air. And then we will try really carefully to get
So you're going to take out, all right, okay, brilliant. And now you're putting your finger over it. Can I help at all?
Yeah, so if you have the flame ready.
No, I put the thing on, right? Yep.
Right,
Here
so
we go.
I
You ready?
will
3,
take-
2, 1. Oh! Oh, I hope you got that. That actually worked, didn't it?
It worked.
That made me jump. Well, I wasn't expecting it to work somehow. I don't know why, but we should never have doubted you, Amber. That was absolutely brilliant. So we ignited the hydrogen, and that's the bang you were talking about in your suck, squeeze, bang, blow, right? So that process of getting, and that's how an engine works in a car, for instance. You bring in the air and the fuel, you compress it, which is your squeeze, ignite it, bang, and that gives you more power and turns the wheels. So that was the bang bit, and we've just done that with hydrogen. And the only thing we got in the air there was some water vapor at the end of it.
Yeah,
so no other...
we just demonstrated that from a really tiny bit of hydrogen that we managed to create power, because you saw that in the flame and you heard it in the noise. So therefore, imagine if we had a huge amount of hydrogen, how much power we could create without damaging the environment.
That is absolutely superb. Well, that's incredible. I hope you enjoyed that at home as well. That was really good. Thank you for telling us your story about and your journey as an engineer. But we hope you preserve some of that energy to take part in, guess what? It's our Engineering Open House Day Paper Plane Challenge now, everybody. I hope you're ready for this. So we'll just move some of this detritus of the experiment over here. In fact, I'm going to get rid of the liquidy bits off, so just in case we don't want to... let me find an assistant over here somewhere. Thank you very much. I'm going to come back round this way. Excellent. So, you know the score, do you? You've got 30 seconds, not 30 seconds,
30.
halved it. You've got 30 seconds now. No, we've got 60 seconds. Other people's are out there. The rules are on the screen at the moment for you at home, but if you find an adult to film this paper aeroplane, if you're going to join in as well, just use a piece of A4 paper. You've got 60 seconds, make your aeroplane. Then you've got to see how far you can throw it across your room, make someone film it as you do it in one continuous film. The distance your plane has flown must be measured on the film. Then you send in the video, submit it to us via Twitter, Facebook or Instagram, and use the hashtag EOHD paperplane and include your child's name and age, as we've 3 prizes up for grabs, 3 different age categories, 5 to 7, 8 to 10 and 11 to 13. There we go. And the competition will close sometime around 3 p.m. BST, which is British Summer Time, on Friday the 27th of August 2021, and the leader in each age category will win the prize. Terms and conditions apply, so please head over to our website before you join in. Whew. Right, that's all that bit. Great. Now, Amber, are you ready for this?
Poised,
We're going to
ready.
count you in with a 5, 4, 3, 2, 1. I'm going to clear my screen. It's on 0, 0. I've got my whistle somewhere. Get the P rattling. Okay, so is everybody ready in the studio? Let's count Amber in with a 5, 4, 3, 2, 1. And she's off. Here we go. We've got... I nearly said 30 again then. There's people shouting you on here. That's because the hydrogen experiment went so well. Very much excited in the studio here. So she's got already about 13, 14 seconds in here. Are you going for a standard dart here, or are you doing something slightly different? The wing's there. Oh, she's going back. She's redoing that little section there.
Refining.
You're on 25 seconds here. There's no panic yet. There's another fold coming in. So it's a double fold dart shape, this one, ladies and gentlemen. 30 seconds we're up to now. It's going very well, though. No panic. It's amazing how people are so unpanicked by all of this. I've still got to do this. It's not going to be like this when I do it, I can assure you. Okay, we've got 44 seconds on the clock now. Just the last few folds here. I think this is going to work beautifully. 10, 9, 8, 7, 6, 5, 4, 3, 2, 1. It's just not working, this whistle anymore. How's that?
I mean, it's a little bit lopsided, but we'll see.
I think this
it might
could
not
be doing
go
all
straight.
right. Well, we know the score now. If you come round to our little runway over here, I shall get the measuring machine ready. And this is where we get to the exciting bit, really. So that you've got your little white lines there. If you take your foot over and you've letting go of it after your foot's gone over, it's a DNF. It's did not fly. Okay, we haven't had a did not fly yet, so it'd be quite exciting to have a did not fly, a little bit. But not from you, Amber. We want this to go all the way because your hydrogen worked a treat. Can't believe it. So where do you think you're gonna?
I mean, I'd like to win, obviously.
Well, at the moment, Dangerous Dan is actually past
Oh
the
my
end of the
God, I
studio
didn't
and
even
right
see
up the other
that.
end by the doors. So he absolutely, I don't know how we did it. We've got it on film, but it's absolutely
I
remarkable.
mean, I feel like I need to do something
you can
for
do
the
a run up.
ladies.
You can do a run up as long as your feet stay behind when you throw it. That's fine.
We're
So are we ready? Let's count Amber in then in 3, 2, 1, go! Oh! That is amazing! It's literally in the dark part of the studio, right up the other end. Not quite as far as Dangerous Dan, I don't think, but we'll get the measuring tool out. That is brilliant. Right, we're gonna get the measure out. Let's have a look down here. Okay. Got 12 metres. Do it one more time. Just get your hand up there. It's 11.71 metres. That's fantastic. Absolutely brilliant. 11.71 metres.
I'm happy with that.
That means I've got to move everybody. That's
Sorry.
brilliant. I don't mind. No, don't say sorry. 11 point. It'll stay on there. We're fine. Keep going. Keep going. Cool. Look at that. You've just jumped over the top of Mr. World. Can you believe it? Right. So Amber, your colleagues will be thrilled. Amber, 11.711 metres. We'll call it a wet track. No, that's a different game. Right, there we go for your car nutters out there. So that's 11.711 metres, Amber. What a fantastic throw. Well done, Amber. You've absolutely smashed that. How do you think it went? Were you
Yeah, I was a bit nervous because the folds weren't great, but it flew and it went straight.
It did go straight. It went straight, and it actually did like acrobatics as it was going. Absolutely brilliant. So Amber, you're in second place. I know that's going to be, there's other people going to be coming in, but hopefully you're going to stay up there on the leaderboard, and we'll see where we get to. So I hope you guys at home are beating our expert engineers. Let's have a quick look, and see if we can get anyone up on the board from anyone at home. I think I've got one actually just come in. Just bear with me 1 second. I think a piece of paper was left over here. Yes. Can we say to Mark that we've had a plane entry? You can say that to me, you can. And I believe somebody's written down from here. We have Alfie, so we're giving you a big shout out, Alfie. Alfie, age 9, he sent in a video, 1.93 metres. You're going on our board, Alfie. So again, that's brilliant. Well done, Alfie. Big round of applause for Alfie. We'll get Alfie up in here. 1.93, that'll be, I have to say it. You're there. Alfie, that's Danielle George, the president of the IET. Above. Well done. Brilliant stuff. That's Alfie. Well, look, it was fantastic you could make it into the studio. We're really thrilled to have had you here. Great to see so many of you taking part. And so, look, let's hope you go back to Siemens. They're all really proud of you in second place at the moment. And we'll see you transforming the energy world in the future, I'm sure we will. Thanks ever so much, Amber.
Thank you.
All right, well, take care. Right, let's bounce back over here. Where are we going next? Well, we're going to be looking at increasingly extreme weather events such as tornadoes, blizzards of snow, really hot summers, and even dust storms. And we're also seeing rising sea levels, which are unmistakable signs of one of the biggest challenges of our time, climate change. And there's lots and lots of factors that contribute to the Earth's climate. However, scientists have agreed that the Earth has been getting warmer in the past 50 to 100 years due to mostly human activities, burning fuel to power factories, cars, buses, and it's causing our Earth to warm up as certain gases in Earth's atmosphere block the heat from escaping back out, and that's called the greenhouse effect. Now, these gases keep Earth warm like the gas in a greenhouse keeps plants warm, leading in the end to a warmer and warmer Earth. But there are so many ways that you can reduce your impact on the planet and help slow down the speed at which the climate change is happening. We have an amazing video now from Amy of Kids Against Plastic, a campaign which was founded by Amy and her sister Ella when they learned just how much of an impact all of that plastic waste was having on our planet. Today, up till today, they have picked up over 90,000 pieces. 90,000 pieces. That's amazing, isn't it? Amazing. 90,000 pieces of single-use plastic litter has been picked up, and they've created an app that you can log it all. And they've presented their own TEDx tool, gathered a whole team of incredible kids from around the UK who are tackling plastic pollution alongside them. Amy's going to tell us about the impacts on our world due to climate change. Let's have a look at this video.
The impacts of a changing climate on the environment are talked about a lot, but tied closely to these are the socio-economic impacts of climate change, the social and economic factors that are influenced by the climate crisis. Changing weather patterns, rising sea level, and loss of species that we're set to experience as the climate changes will all have serious adverse impacts on humans and the resources that we rely on. For a start, climate change threatens one of the key resources that we need to survive: water. Not only will migrating jet streams cause a different spread of rain and snowfall, as covered in last episode, but we're also losing a key source of year-round freshwater from melting glaciers. The meltwater from mountain glaciers in the Himalayas and Kilimanjaro are relied on for irrigation and drinking water by the populations in these regions. The loss of just the Himalayan glaciers could result in 1 billion people losing their primary source of fresh water. And water is relied on for a lot more than just basic survival. It's also intrinsically linked to global food systems and energy production. Water is required to generate renewable energy through hydropower, but it is also required as a coolant in nuclear power plants. Reduced river flow to power plants due to climate change could make it more difficult to generate energy in these ways. When it comes to food systems, a warmer climate also means that more water will evaporate from the soil in regions where water is already in shortages. This means that there will be adverse effects on soil fertility and therefore crop yield. Experts say that this will create conflicts within and between countries for limited supplies of water and land for food production. Malnutrition already kills an estimated 7 million people per year, with a further 2 million killed by complications due to lack of access to fresh water. The negative impacts of climate change on food and water availability are only expected to magnify these numbers. That's why climate change is expected to cause a rise in the number of climate refugees, people who have been forced to flee their homeland due to climate change making them uninhabitable or unfavourable to live in. This could be due to intense drought or biodiversity loss, or even displacement due to intense storms or sea level rise. Sea level is expected to rise by up to 6 feet by the end of the century, threatening populations that live in coastal regions and reducing living space. Paired with storm surges and intensified hurricanes, and it becomes even more dangerous. According to the World Health Organization, rising temperatures and changing precipitation patterns due to climate change have already claimed over 140,000 lives. But if you're sitting in a country in the global socio-economic north like I am, then you might be lucky enough to think, if this changing climate is also bad, how come I haven't experienced anything like this? Well, the chances are you have actually experienced a consequence of climate change in one way or another, whether through a particularly hot summer or a particularly snowy winter. But this unequal suffering caused by extreme climate events links to a socio-economic point and a matter of social justice. It's those who have contributed the least to climate change that'll be the hardest hit by its effects. A study into climate vulnerability found that the 10 countries in the world most threatened by food insecurity are responsible for less than half a tonne of carbon dioxide per person. Collectively, that's just 0.08% of the total global carbon dioxide released. Climate change also goes hand in hand with racial injustice, where BIPOC communities are more likely to be impacted by the consequences of the climate crisis. For example, in the aftermath of Hurricane Katrina, 80% of people living in the flooded areas were non-white, and the indigenous people in Brazil have a high vulnerability to climate change, despite being guardians of their traditional territories and respecting the environment they inhabit. To be able to deny the existence of climate change is a privileged situation to be in, as there are already millions of people around the world who are suffering its consequences, or are set to lose their livelihoods or even their lives. And for anyone who comes from a stance of climate change denialism, remember, unless we take urgent action to curb our emissions before it's too late, the consequences of global climate change will negatively impact us all.
Wow, Amy and Ella are just doing a fantastic job. They're really, really brilliant. So what action do we need to do? Well, there are many things we can do within our own homes to reduce our footprint on the planet, including recycling, which I am not joking. The last 3 or 4 years, I have started recycling everything. And our black bin, which is just the general waste, is only ever about this full now, whereas the green recycling bin is full, and the waste bin from all the food, it's just incredible. So you too can reduce, everybody can reduce our single-use plastic of water bottles. We can buy locally sourced produce. You can have a plant-based diet, for instance, or just a little bit more of a plant-based diet than before, and that will help too. Even reducing our water use within the home. So let's hop over now to India and visit FluxGen. And FluxGen, who are going to show us the cost of water on our world and how they're helping India to become water positive with their new technology.
Industries are huge guzzlers of water. Do you know how much water does it take to make a pair of jeans? 7,600 liters. And guess how much a dairy uses every day just for cleaning? More than 1 lakh liter of water. By 2040, most of the countries would not have enough water for their basic needs. The only way to stop this is to become water positive, especially by industries. Being water positive means to reduce wastage and leakage, recycle most of the water, and use methods like rainwater harvesting to meet the rest of the water requirements. As a consumer depending on these industries, our indirect water footprint is much larger than the water we directly consume on a daily basis. But what if industries could minimize their water consumption? What if a dairy used only 45,000 liters instead of 90,000 a day? If 20 dairies did the same, they would be able to save water the size of a lake every year. This is exactly what FluxGen helps industries do. Our technology enables industry owners and factory workers to use water as efficiently as possible. Aquagen monitors the entire water infrastructure of a factory and prevents wastage. We have flow sensors set up in pipes and water level sensor in tanks. All of these are connected by IoT to the cloud. Our devices even measure the energy that water pump and the recycling equipment consumes. If an anomaly such as leakage is detected, it alerts the worker on the phone app. There's also a dashboard where managers can see their consumption pattern and take corrective action. We've seen a huge positive behavioral change in water consumption by our customers. For example, the Winner Dairy in Puducherry has cut down their water consumption by 30,000 liters a day in just few months. This has also cut their electricity cost by 15%. There's a direct financial benefit in managing water consumption. 10 years ago, this level of automated water monitoring wasn't required, but now it's essential. As our problems change and new ones come up, our solutions have to keep evolving. Like during the recent lockdown, our team couldn't travel to other states to deploy our product. We took this as a challenge and we found local partners in different cities to set up our systems. It also pushed us to redesign our device and make them more plug and play. So now we are in a position to take our technology anywhere in the world. My goal is to make our lives water positive because there's no substitute to water, right?
Wow, so FluxGen are using data to detect how much water they can conserve and how they can reduce their consumption, as well as their electricity costs. And they're also testing your water knowledge on our Media Hub. So make sure you head over there and see whether you can guess just how many bathtubs of water it takes to make a pair of jeans. For the IET's 150th anniversary celebration, we have been hosting a whole range of activities, including this Engineering Open House Day. But we've also launched our 150 Sustainable project aimed at children just like you at home. So let's have a look at our video.
Hello everyone and welcome to the My Sustainable Community Competition, a project designed to celebrate 150 years of the Institution of Engineering and Technology. Throughout this project, you will be exploring the fundamentals of sustainable living and using your new knowledge to help you design your very own sustainable community. Now, humans have impacted the physical environment in many ways through overpopulation, pollution, burning fossil fuels and deforestation. And changes like these have triggered climate change, soil erosion, poor air quality and undrinkable water. Now we're fortunate that most of us live comfortable lives with almost everything we want. But unfortunately that might not always be true. In the future, we might not be able to have the same things because the raw materials and resources may run out. To make sure that future generations enjoy everything that we enjoy today, we need something called sustainability. Sustainability is something scientists, engineers and governments are working together on to solve today for everyone's future, but we need your help. Sustainability is the idea that humans must interact with the environment in a way that ensures we stop harming our planet and allows for enough resources left for future generations. The My Sustainable Community Competition encourages you to consider a community response to the sustainability and climate change problems we are facing. Whilst learning about ways we can improve our future, you can also get to explore the world of STEM. That's science, technology, engineering and maths. You'll gain fantastic problem-solving skills and have valuable experiences which you can talk about. So, what exactly is the My Sustainable Community Competition? Well, you are required to design and build a sustainable community, similar to the community that you live in. Imagine an open piece of land and nothing on it, a blank canvas, and that's where you begin. Your community needs 150 homes to accommodate the residents, and the rest is up to you. Your community should consider the needs of people that live there, whether that's the water supply, heating, food, transportation, services, and the promotion of healthy lifestyles. The great thing about this project is you can adapt it to your own interest. So if there's something in your local community that you would like to make more sustainable, perhaps you could focus on improving that. Or you could look at exploring different communities around the globe and see how people are making positive changes to live a more environmentally friendly lifestyle. For this project, you're expected to complete a competition portfolio and accompanying models. The portfolio should be made up of the following sections: title page, contents, overview, introduction, research and analysis, procedure, design, and conclusion. Your models should be made of renewable, sustainable or recyclable materials, and depending on the class of the competition that you've entered, you could be building an entire community, a section of a community, or a specific area of that community, focusing on whether that's energy generation, transport, or a particular service. Digital and concept models can also be submitted. Your handbooks and the supporting PowerPoint has all the information needed to get you started. So, best of luck with the competition, and we can't wait to see the communities that you design.
So there you go. If you think you could enjoy that competition and get applying, and you can find out more information about how to get involved on our Media Hub. that has brought us to the end of this episode, all about energy and sustainability. We've learned so much in the past hour, including how all of us can make small changes that will lead to big changes in the future. Hope you've enjoyed Engineering Open House Day today. Before we get another sweet fix from Andrew with his baconeering, I want to see more of your #EOHD paper plane videos on our social media board, and we'll shout you out. So let's get up and have a look at those things when they come in. Oh, I think we've got a couple coming in now. Oh no, this is from Thames Water, I think, from Glen. Water plays a key role in our everyday lives, but have you ever thought about how it gets to our taps? Join Thames Water as they reveal behind-the-scenes journey through how water gets from A to B. Brilliant. And this is all about Automotive Innovation Centre is opening our virtual doors at GKN for the IET's Engineering Open House Day on the 23rd of July. So thank you for that shout out there. So remember, our entries close at 3 p.m. on Friday, August the 20th. Sorry, what day was it again? Right, it was. Our entries close on Friday, I think, the 27th of August, 2021. Lots of twos in there. And we want you to get up on our leaderboard right now. So to get submitting your videos to social media, please, and we can stick some more of your names up on our board. Remember to put your name and age if you want to be in with a chance of winning a cool STEM prize too. Remember, those terms and conditions apply. So head over to the website before you submit your entry, and make sure that you also head over to our Engineering Open House Day Media Hub, where there is still plenty going on for you for the rest of the day, including a virtual escape room with the Aberdeen Science Centre, or you can learn how to solve problems like software developers with rocket makers, as well as taking a 3D tour of Billfinger UK. So that sounds really exciting. Now, in our next episode, I'll be joined by Ruth Amos from Kids Invent Stuff as we predict what the world of science, technology, engineering and maths will look like tomorrow. But before that, we have Andrew Smith back again with some more baconeering. What have you got for us this time, Andrew?
Today, I'm talking all things materials engineering, specifically sweet shop fracture and fracture mechanics. Now, I have to say, this was inspired by my good friend Anna Porszajski, who I first saw doing one of these demos at the FameLab UK final in 2017. And these are all things that you can find at your local corner shop. So what do polymers have to do with things you find at your local sweet shop? Well, let's explore. So let's start talking through the different forms of fracture that we get. And the first one is ductile fracture. Now, ductile fracture is usually when things are a little bit stretchy, and usually before things fail you get a little bit of warning. So if I start to pull on, say, some strawberry laces, they start to get a little bit thinner, and that's called necking, where they start to thin at the middle before breaking. And that's the same thing that happens in metal. If you slowly pull a metal rod, it thins slightly in the middle, voids start to coalesce, and then it eventually breaks. And in a metal that might give you quite a mottled, dull looking surface. On the other hand, something that's brittle, say chocolate crystals, or specific metals, if you hit them hard enough, they tend to snap. They leave a clean surface. You don't get much warning before they break. It tends to be quite sudden, but often they can be a little bit stronger than their ductile counterparts. But it's not quite so straightforward as this, because it's not that materials are either ductile or brittle. Often they can change between the two. And specifically when it comes to polymers, this happens at something called a glass transition temperature. Now, when it comes to foodstuffs, things like caramel, the glass transition temperature from when things go from behaving brittly to in a ductile way is around about room temperature, which is very useful for our sort of experiments. So the first thing to talk about is temperature dependency. And what I have here, just the humble Snickers bar, and believe it or not, there are academic papers on ductile brittle behaviour in caramels with varying water percentages, so go look that up at home if you're interested. But at room temperature, when I break a Snickers bar slowly, it's a ductile fracture. So we get plastic deformation. As I stretch it, the bonds are able to easily break, slide over one another, and reform on a microscopic scale. So I get quite a long, drawn-out caramel. I'm sure this is making you hungry at home. But if we lower down to a Snickers bar that's come straight from the fridge and I break it, it breaks in two. We've gone below that glass transition temperature and we get a brittle fracture. So what happens is that the bonds are no longer able to shift and reform. So any small cracks quickly propagate through and we get a very sharp fracture surface. And the same thing happens in polymers. If you've got a polymer that's a bit colder and it's impacted, it's more likely to shatter and break rather than fail ductilely. The second thing comes down to strain rate. Now notice when I broke this first bar, I did so quite slowly. And this is where Anna's genius came in, is she realised in the same way as polymers, if they're hit at a much higher speed, those molecules don't have time to reform those bonds. If you hit a Snickers bar fast enough, you can force it to fail in a brittle way at room temperature. And that's what I'm going to try to do. And it requires a bit of a karate chop. So let's go over here and try that out. Now it's all in holding it firmly over the side and going for a short, sharp shock. Now the karate chopped Snickers, something you don't see every day, has exactly the same failure as the fridge cold version. So both low temperature and high strain rate give you the same results. More brittleness when it comes to polymers and Snickers in this case. But actually, if I was to load it slowly, having a higher strain rate or a lower temperature actually makes them a bit stronger too. So it depends what you need for your application. And polymers behave in this exactly the same way, which is why when it comes to automobile applications, any new material has to undergo testing at 2 different speeds to fully understand its performance. So it's not all about the energy required to fail a material. It's all about the failure mode, be that brittle or ductile, because that can affect the safety of a component. If something fails brittly, it might break off into small pieces and travel around a machine. So if you're thinking of using Snickers in your next sweet shop fracture project, be sure to have done your own karate chop experiments at home first. But the results are fairly delicious.